Welcome to Lesson 8.1, Part 2, Pythagorean Theorem and its Converse. Okay, is this figure a right triangle? So, how the converse works. Yesterday you learned about the Pythagorean Theorem, and we were plugging in for the Pythagorean Theorem, which is, a squared plus b squared equals c squared. And we were asking you to solve for a side. Now, this only works for right triangles. The converse is we're trying to find out if this is a right triangle. And what you do here is you just plug in your numbers. Now, what's important when you plug into the Pythagorean Theorem is that you always take the longest side. Don't go by looks, that looks like a right angle, because we don't know that yet. The largest number always gets plugged in for c, and the other two sides are your legs. So, how you would plug in your numbers is 15 squared plus 13 squared equals 25 squared. When you work it out, after you square and add, you find out that your numbers do not come out the same. This is not equal to that. So the answer is no, this is not a right triangle. Okay, make sure that you're writing down the examples. That's how I know that you've taken the notes. Example 2 is the figure at the right triangle. Now, again, you got to look at your three numbers. Don't go by looks of the triangle. Pick the largest number. That number is going to go in for C. So when you plug in this time and you work it out, after you square first and then add your numbers, this time you get the same thing on both sides. Okay? So that means the answer is yes, it is a right triangle. Okay, Pythagorean triples. Pythagorean triples are sets of whole numbers that satisfy the equation a squared plus b squared equals c squared. That's because that's the Pythagorean theorem. So if these numbers work into the Pythagorean theorem, okay, then it's called a Pythagorean triple. These are only true for whole numbers. Now there's lots of triples, and we'll talk about this more in class. Here's a list of some of them. Now once you start seeing some of these, you're going to start recognizing them as triples, and it kind of saves you some time. So for example, up here, the smallest triple is 3, 4, 5. Okay? That means 3 squared, which is 9, plus 4 squared, which is 16, has to equal 25. Okay, remember your biggest number, not just the third number. Look at your triples. The largest number always goes in for C. So 3 squared plus 4 squared equals 5 squared, and 9 plus 16 does equal 25. So all of these triples are going to work in the Pythagorean theorem. That's why they're called triples. Oh, and by the way, I strongly suggest you either print out this page or maybe write those down so you can, have them in your notes so you can recognize them quicker. Okay, Pythagorean inequalities. Last thing we're doing. If this is an equal sign, then that's a right triangle. Okay? If a squared plus b squared equals c squared, it's a right triangle. But let's say you go to plug in and a squared plus b squared is greater than c squared. That means you're going to have an acute triangle. Okay? Because your hypotenuse is smaller than the sum of your two legs. If it works out the other way, where a squared plus b squared, that number comes out to be less than c squared, then it is an obtuse triangle. Might be helpful to write that down. All right, so your final example says classify the following triangles as acute, obtuse, or right. So again, you're plugging into the Pythagorean theorem. Okay? The largest number is going to be your hypotenuse. Don't go by order. That's not always the last number. Sometimes I make it the first number. Oh, there's my highlighter. Okay, so this is going to be my hypotenuse in this one, and this is going to be my hypotenuse in this one. So that one goes in for C, the other two go in for A and B. It doesn't matter. So when you work out this one, okay, we end up getting two different numbers, so we know it's not a right triangle. And a squared plus b squared is less than 576, so that means it's going to be obtuse. When you check the other ones and you plug in, you're going to go ahead and plug into the Pythagorean theorem and work it out. Again, the numbers are not equal, so it's not a right triangle, but this time a squared plus b squared is greater than c squared, so now it's an acute triangle. Okay, you have an extra credit problem. You might want to pause it so you can write it down. I will help you if necessary. You can turn it in on with your checklist for next week. And your assignment is going to be a handout. If you wanted to try to get a head start on it, it'll be in the assignment folder. And if you want to work on it in class tomorrow, you can work it on in class. It will be due Monday. Okay, bye-bye.